This is Integrated Math 1's topic 8-4, transforming exponential expressions. The main idea here is we're going to be changing the units of an exponential function. So let's start out with a basic example. So if I start with $10, our initial value is 10, and I gain 5%, again, 5% as a decimal is 0.05, and that's interest each year. And the key word here is this is each year. So another word for each year is this word annually. Annually is the same thing as saying each year. So the main question is, if we were the bank, can we offer a different interest rate that compounds monthly? So we're changing from annually into monthly and still get the same amount every year. So it's not going to change by giving us more money now that we're compounding. I just want to convert units. So if you start with this amount, how can we modify it so that it's every month as opposed to every year? And the general idea here is you kind of pull this one apart and you say, okay, I want this t to be raised to the power of 12. So I want to multiply this by 12. And that's basically, we're done. But the problem is I can't just willy-nilly multiply by 12. I also have to divide by 12 somewhere else. So I'm going to do that right here, times 1/12. And you'll notice that the 12 and 12 cross cancel. So it is exactly the same equation. And it seems like I haven't done anything because I haven't really. But one of the cool tricks that I can do now, and let me move some things around so that I have a little bit more space. I can move this 1/12, I can move that inside here, and I can get a new equation that looks like this. I can say y is equal to 10 times a quantity of 1.05 to the power of 1/12. And that's all multiplied or to the power of 12t. Again, one of the properties of exponents, and I can write this off to the side, if you have some x to the power of a and you take that to the power of b, a power to a power multiplies, and you can say that this is the same thing as x to the power of a times b. And some people just say AB because you squish them together, but I prefer having that little dot in the center to say, yes, they do multiply. So these two are exactly the same. And again, it seems like I haven't really changed anything because that's not too big of a change. And here is where I'm going to change things. This 1.05 to the power of 1/12, I can figure what that is on a calculator. So I can come over here, let's do my split view, and come over to my scientific calculator, which I can clear all of my stuff off of. And I can say, what is this 1.05 to the power of 1/12? And that is the decimal. And here, let me get some room to write. This is now going to be y is equal to our initial value of 10. And now our decimal is not 1.05, it's 1.00407. I don't know when to stop rounding because I haven't talked about significant figures, and that's all to the power of 12t. And now this works. You can see, like here, I can prove to you that works. Let me open my calculator back up. If I come back over here to my calculator, in fact, I'm just going to prove to you like this. If I have this entire thing, again, let me put parentheses around this and take it to the power of 12t. I know it doesn't look like it's the power of 12t, but I promise it is, because if I type in a normal number, it's down there. So you can see that 12t is the power. And then what if I take just 1 point, I guess this is kind of silly, isn't it? So hold on. Let me make this cooler. So I'm going to type in, I'm going to store this variable, or I can just type it in. Here, I'll just type it in. I'll say 1.00407 4124. I hope that's exact enough. And I'm going to take that to the power of 12t. Okay, let's do that one versus 1.05 to the power of 12t. 12t. All right, so at first it seems like, okay, you can't do anything, but watch what happens when I do t values. If I do t values are equal to 1, those are, oh, I shouldn't have a 12t up here. I'm being silly. So I'm going to come up here and say, this is the value of just t. There you go. And you can see 1.05. Again, this top one is off by a little bit because I rounded just slightly. If I do a value of 2, you can see they're nearly the same exact numbers, 1.1025. If I change this to a value of like 12, they should be very, very similar, 1.7958. Yeah, so these are exactly the same. If I had stored this perfectly and not rounded to, what is this? 1, 2, 3, 4, 5, 6, 7, 8. I rounded to 9 decimal places. If I had an infinite number of decimal places, it would be infinitely correct. So that's how you convert everything. Let's go ahead and try to do some examples now. How would this apply to some other problems? So let's find the equation that gives 2% annual interest. That means every single year. So 2% as a decimal, I can say 2% as a decimal is the same thing as 0.02. Again, you have the decimal place right here, and we move it 1, 2 to the left. So it'd be 0.02 or 0.02. So that means if I'm setting up my equation, I would say y is going to be equal to my initial amount, which I don't know, so I'll just say some initial amount times 1 plus, because I'm going up by 0.02, 1 plus the 0.02, and again, that would be to the power of t, and that converts down into y is equal to some initial amount times 1.02 to the power of t. Okay, so now we want to convert that equation. What would that same equation be if we compounded the monthly, or compounded monthly as opposed to annually, and we still want the same amount of money? So again, I would do kind of the same thing I did before. I would say, okay, I have the equation y is equal to some initial value that I'm just going to call I for now, and I'm going to say that's being multiplied by 1.02, and I don't want to have this to the power of 12t, or I don't want it to the power of t, I want it to the power of 12t. So I'm going to say to the power of 12t, but I can't do just willy-nilly power of 12. I need to also divide by 12. So I'm going to have the 1/12 over here. And this is the exact same process that we did before. So I say, okay, now y is going to be equal to that initial value times 1.02 to the power of 1/12. 1/12, that's, I can write a little bit neater, 1/12 to the power of 12t, and then I can figure out what is 1.02 to the power of 1/12. And again, let's pull back up our calculator, and we can say, I can clear everything. I can say, what is 1.02 to the power of this fraction 1/12? And that's going to be this new fraction, which is, or this new decimal in pen. It's going to be y is equal to our initial value times 1.00165. 165. I don't know where to round, so I'm just going to stop right there. That seems like a good place. To the power of 12t, and we're done. So I guess the extra question that I'm not asking here is, well, if 2% was the annual interest rate, what is the monthly interest rate? And I can say, okay, well, I move the decimal place 1 to the back, and I would say it's 0.165%. So you don't have to answer this, but it is 0.165% monthly rate. Monthly rate, which is kind of interesting to think about, right? So if you have 2% annual rate, it's the same as a 0.165 monthly rate if you compound on a monthly basis. All right, and this is a much more applicable question, although does it transfer to the real world? Probably not, and I'll talk about why, hopefully, if I can remember that. Which bank offers a better interest rate? Is it 3.1% annually or 0.7% quarterly? Quarterly, by the way, is a way of saying 4 periods in a year. So you get 4 compound interest in that 1 year, and annually you only get 1, just at the very end of the year. So there are 2 different ways of solving this, and the textbook shows both of those ways, and I would like to show both of those ways. The one that makes the most sense to everyone is just to convert everything to an annual rate as opposed to a quarterly rate. So that means I don't have to change A because it's already annually. I just need to change B from quarterly into annually. And notice we're going backwards here compared to the last 2 examples. These last 2 examples, I had something that was annual, and I'm trying to go into smaller intervals, meaning that this was a power of 12. And now I have something that's already smaller intervals, and I need to go up to annually. So instead of having a 12 up here, I'm going to have like a 1/4 up here. So just be ready. Here we go. I'm going to start with my normal equation. My normal equation here would be y is equal to some initial value times 1 plus the interest rate. Here, let me convert the 0.7. So I say 0.7% is the same thing as, let's move the decimal place 1 to the left. So it's going to be 0.007. So it's going to be 0.007 as a decimal. So if I add 0.007 to 1, I get 1.007. I'm seeing 007. If you've ever seen James Bond, you'd think that too. And this is going to be to the power of just t. So I want to convert this into, it is quarterly right now. So to get this out of the quarterly, I need to say that this is, let's move this to the side a little bit. Okay, I can do it in 2 steps. I'll do it like this. I want to, okay, for the notes, I should show that step. I shouldn't move that around, should I? Okay, so y is equal to some initial value, and this is going to be times 1.007 to the power of, well, I need to make sure that this is less than it is. So this is going to be 1/4 of t. And again, in order to make sure that things cancel out, I'm going to have 4 times 1/4. So from here, I'm going to move this 4 into here, and I'm going to say that this is, here I need a little bit more room. Let's go ahead and move you down just a little bit. This is going to be y is equal to my initial value times 1.007, that was about 7 to the power of 4, and then to the power of 1/4 t. All right, and from here, I can say that this is the same thing as 1.007. Well, wait, hold on. What is 1.007 to the power of 4? Let's go figure that out. So split the screen so I can see what's going on. And this is going to be, just type in, let's clear everything. It's going to be 1.007 to the power of 4. And that is, y is going to be equal to some initial value, and then it's going to be times 1.028. 1.028. And then I guess 295, I can put the 295 as well. So say 295 to the power of 1/4 of t. And what is this effective interest rate? Well, for the interest rate, you kind of ignore the 1, right? Because the 1 is just there to make sure that when you multiply by 1, nothing happens. And so I'm looking at this 0.028, this part of the fraction, and if I move the decimal place 1 to the right, this is 2.8. So this is essentially 2.8295% annual now. So we've converted from quarterly to annual. You can say, okay, well, which one is better, 3.1% or 2.8%? And you'd say, well, I want more money. I want I want the 3.1%. So that's how you can convert, and that's why you'd want to know how to convert between the two. If some are offering quarterly versus annually, you'd want to know. So here, let me talk really quickly before I jump into method 2, why this is not necessarily a real world example. I personally, in the United States, have never seen a bank that offers quarterly versus annually. Everything is on a monthly basis for banks, and it's astronomically low. Like, all of these numbers are crazy high. You'll get like pennies on the hundreds of dollars. It's super, super low. So not necessarily a true worldly example, but I do want to talk about how to go the other direction. How would I convert both to quarterly? How would I convert this annual to quarterly? Well, I'd start with an equation, right? I'd say y is equal to some initial value times 1 plus that percent. That percent is 3.1. So let me convert that. So if I have 3.1%, if I want to move that into a decimal, I'd move it 1 to the left. I'd have 0.031. So this is going to be equal to 0.031 as a decimal, and I'm going to add that number to 1. So it's going to be 1.031. 1.031, and that's going to be to the power of t. And now I'm going to convert that because I want this to be quarterly, so I need to essentially have 4 of those. I need to have 4 times I'm compounding, right? So it's going to be 1.031, and I want 4 of those times that I'm compounded. I need to rewrite all this other stuff to the left. And if I multiply by 4, I also have to divide by 4, and therefore this one in here is going to be to the power of 1/4. So I can say, what is that? Calculator, pull it up. Let's see what we got. This is going to be 1.031 to the power of 1/4. Or I guess I could have done to the power of 0.25. And you'd see, okay, well, this thing is going to turn into, and then y is equal to what is this going to be? Some initial value, right? Don't forget our initial value times 1.00766. We'll do 1.5 and call it good. Yeah, 1.5 to the power of that 4t. All right, so what is this effective interest rate? Again, you kind of ignore the 1 because that's just doing nothing. Multiplying by 1 does nothing. And this is moving the decimal place 1, 2. It's going to be 0.766. So you can say this is 0.76615%. And that's a quarterly rate, not an annual rate. So that's a quarterly rate. And then you could theoretically compare the quarterly rate to the quarterly rate. You'd say, okay, well, this one is 0.766 and this one is 0.7. Which one would you want? Well, I want the bigger one, so I'd still go with option A. So two different ways that you could approach the same problem. This one doesn't make so much sense, but I do want you to see the difference between initially trying to get the 1/4 here versus the 4 here. So I'm imagining one of the things that you're going to want to remember in this bottom left of your notes is when to have a 12 versus a 1/12. The general idea is how many times do you want to compound, right? So if you have something that's annual, that means that you're essentially having a 1 up here. This number is a 1. If you want to compound it 12 times, there should be 12. That is the number of times that you compound. Like, remember down here, we said that we had an annual rate and we wanted to compound it quarterly. So we need a 4 up here. So whenever you want to compound more times, the general number that's left in your formula needs to be the number of times that you compound. And then the reverse is true, right? If you are compounding 4 times already, to undo compounding 4 times, you need to multiply by 1/4. So you are now compounding 1 year. So that's why we wanted that 1/4 right there. All right, well, that was kind of a long-winded explanation of maybe what is a simple topic. That does conclude our lesson for 8-4, transforming exponential expressions for our class. Thanks for watching, guys.